Hello everyone, welcome once again to another Power BI dashboard related tutorial. In this part we are learning about creating a inventory management and analysis dashboard. So the data set that we got from GitHub, in the data set in the Power BI file, there was this dashboard and we are trying to explain how various calculated columns and measures in the dashboard are created. The interesting thing about this dashboard is creation of ABC and XYZ classification. ABC classification categorizes inventory based on importance and value, and XYZ classification groups inventory by demand variability. This particular dashboard tutorial will be in several parts. In the first part, you will understand the usage of calculated tables, calculated columns, all these type of measures that you are seeing here. You will learn how to create these measures and you will learn how these formulas are used and use of different type of functions and how we have categorized the data, how the week table is created, how week demand sheet is created, how SKU table is created by grouping or summarizing the SKU ID. Everything will be taught in this tutorial, and once you have the hold of these particular measures, particular calculated columns and tables, then we will learn how to create this type of visuals or any other type of visuals from this data set. So let's get started with it. Let's understand. Now this particular dashboard was received from this particular URL. One of our student was searching for some samples to practice Power BI. So got this data set, and in the GitHub we have the data set in two parts. First is the past orders table. So in the past orders table we have order date, SKU ID and order quantity. Like these are the past orders that were given to the company, and these are the SKUs of those products which were ordered. Then we also have stock information. So those SKU IDs are referred here also. So we have to kind of merge these two tables in order to get the full information. And that's why in Power BI modeling we can create that. Now there is a current stock quantity unit, that is numbers per kg, and this is in kg. Most of the units are in kg as given here. Average lead time, that is what is the lead time in days, and maximum lead time in days, and unit price. And this project delivers an inventory management solution using Power BI. ABC classification categorizes inventory based on importance and their value. XYZ classification groups inventory by demand variability. Inventory turnover ratio can be done here. So measures how efficiently inventory is utilized, and safety stock levels etc. will be discussed. And visualization used are stock stack area chart, displays average and cumulative data for ABC classifications etc. So to get started, just open Power BI, and in Power BI simply connect the Excel workbook and connect that Excel file. So this is a blank Power BI. We'll connect on Excel work and connect the Excel of this inventory management product or project. And here you can see two tables. One table is past orders and one table is stock. Make sure in both the tables columns are properly visible, and then load the data. Once you will load the data, both these tables will come in your data pane. Now you have these tables. Go to the table model view and see that the proper relationship between the SKU ID between two tables is created. This model is automatically created based on the SKU ID name here as given in the data set. Now after this we will create some calculated tables. The first calculated table here is the SKU table, where we are using the summarize function, and in the stock table that we have. So in the stock table, we are using stock SKU ID to summarize it. So to do that, just go to modeling view, click on new table and in new table you can just write the summarize function. So basically summarize function creates a summary, the input table grouped by the specified columns. So we are grouping by SKU ID. So this will simply create our SKU table and it will be available like this. So for example, in our main tables, this stock ID may be different, right? Or in our past orders table, we might have repetitive values of stock ID. So this is simply grouping the data and creating a separate table for us. So remember the function here, DAX function, that is summarize. And with summarize, you use stock. Okay. So stock is the name of table, and then you are selecting the column with which you have to group the data. So we have created first calculated table, that is stock table. Then in order to analyze total sales amount by week date, they have done, they have created a week table. So let's copy this. Now we will go to home tab once again, and again we have to create another model. So first we will go to report view, and in report view we will go to modeling tab once again, create a new table. In new table we are using generate series. So the generate series function takes start value, end value, and increment value. It returns a table with one column populated the sequential values from start to end. Okay, so that's why in our generate series we are providing a start value, that is they have provided 14062020 minus 365, and then the end value they have taken is 14,6,2020. So this will simply create a week table in the data set that we have. So in our data that we have, so in the past orders, the last value that we have is 13 June 2020. And when you will sort at ascending, so first value is 13 June 2020 and this is 30 January 2019. So as per the last value, okay, this is the last value, this week table is created. So 20 June, 14 June 2020 minus 365 to 14 June 2027. Okay. And in generate series, why have we used 7 here? Because in generate series, you will you have to provide the weekly data, right? You have to create the weekly data. So that's why in generate series, the increment value is 7. So this is the start date, that is 14 June 2020 minus 365 days. So start 1 year ago and end at 14 June 2020 and with an increment of 7. So in the week table, every date that will be created will be from the start date given here. Okay. So here, for example, we have different values, date hierarchy. So if you go to day, okay, so you can see it is starting with 15, then next value is 7 days later, then next value is 7 days later, and so on. And time it has already given 12 a.m., that is start of the day. So this way, week table is created. You can use the generate series function to create dates between different intervals at your specified interval also. At your specified interval step. Now, next important table here is weekly demand sheet. Okay. So because you want to see weekly demand of products, so weekly demand of SKUs. So in your weekly demand sheet, what you have done, you have used the generate function. Okay. So in generate function, it will take input from both the tables. So first we will go to the report view here and modeling. We will create another calculated tables. In weekly demand sheet, in generate, you have to put two tables, right? Table 1 and table 2. The second table expression will be evaluated for each row in the first table. So like in table 2, that is in SKU table, we have all unique SKU IDs. So the second table expression will be evaluated for each row in the first table. So in week 1, in the data set, all SKUs, week 2, all SKUs, week 3, all SKUs, and so on, right? So that way, this evaluation can be created, and that is the use of this generate uh, function. This will create a table for us, that is weekly demand sheet. Now, when we will go to table view, you can see in weekly demand sheet for date 15, we have all the SKU IDs. For date 16, you will find all the SKUs ID. So this will be a long table, and you can see it has 16,059 rows. So now they have past orders, SKU table, the stock information, the weekly table, and the weekly demand sheet. Now in weekly demand sheet, we will create a calculated column, and that calculate this table, the calculated column is the sales amount. And for sales amount, we have to look up the unit price value from the stock table. Okay. So in the stock table, we have SKU ID and stock status. And so here they are using lookup value. First in lookup value, we are selecting unit price, then unit ID. Then in weekly demand sheet, we are using SKU ID and multiplying by week's demand. So let me explain this particular expression to you. So here is the simple explanation of this. So the DAX formula is sales amount is equal to lookup value, stock unit price. So in our stock table, we have unit price. Okay, unit price. And in our stock table, we have SKU ID. We also have weekly demand sheet that we have. So let's collapse this. In weekly demand sheet, you have SKU ID, which we just created. That means for each week date, every SKU ID. And in weekly demand sheet, we have week demand also. Okay. This week demand will be calculated like this. So first we'll explain that. So this particular DAX calculates sales amount for each item by combining data from tables stock and weekly demand sheet. So by combining data from two tables, stock and weekly demand sheet. Lookup value is stock unit price, stock SKU ID, comma weekly demand sheet. This part retrieves the unit price of an item from the stock table. How it works? It looks into the stock table unit price column, matches the SKU ID from the stock table with a corresponding SKU ID in the weekly demand sheet. Okay, and returns the unit price for matching SKU ID. If the stock table contains SKU ID, unit price, so let's see this example. So here is a proper formatting. So if the stock table contains SKU ID and unit price like this. So SKU ID 101, let's say price is $10. SKU ID 102, price is $20. So and the weekly demand table contains SKU ID 101 has a weekly demand of 5 and SKU ID 102 has a weekly demand of 3. So it returns $10 for SKU ID 101 and $20 for SKU ID 102. And then we are multiplying by weekly demand sheet. Multiplies the retrieved unit price by corresponding value in the weekly demand table. So for SKU ID 101, unit price is 10 and weekly demand is 5. That's why the sales amount will be $50. Similarly, for SKU ID 102, unit price is 20 and weekly demand is 3. That's why sales amount will be 20 into 3. So that's why we are simply are looking for a value. So for unit price and stock ID from the stock table and SKU ID from the demand table, and then we will multiply by demand sheet. Now we have understood that we have to get weekly demand also, right? What is the weekly demand? So we have to create one more calculated column here that will create weekly demand for us. For weekly demand, we have created a column called weeks demand. So to do that, let me show you step by step. So go to modeling table, make sure you have selected the weekly demand sheet. In weekly demand sheet, we will create a new column, and that column will be weeks demand. We are using the calculate function. The calculate function takes expression as our first filter, and it evaluates an expression in a context that is modified by the filters. So calculate the what we have to do. We are using past orders or order quantity. So we are trying to find out total number of orders, total number of quantity of orders that is given in the past order. So in past orders table, we have order quantity here. Okay. And here in past order quantity, we have, then we are applying a filter. So in past orders, what we are doing is we are saying in past orders SKU ID should match week demand sheet SKU ID, and past order date should be greater than week demand sheet week date and -6, and past order date should be less than equal to week demand sheet week date. So that's this way, by applying these two filter with logical and operators, we can find this information, and this way we will be able to create week demand. But before calculating the week demand, we have to create week date column also, and week date can be easily created with the help of generate. So in generate, as we did, we have two tables, week table and SKU table. So in SKU table that we created, we have SKU ID, right? So this is a week date for us. So here, just the value column has been renamed as week date. So like when we will create it for the first time, so we have the value. So if you will simply go in the weekly demand sheet, so you can see value and SKU ID. So you can just rename this column as value. So we will just go and rename this column as week date. Okay, because this is basically the week date. Okay, and now after creating this, when you will simply copy the entire week demands calculation to create this calculated column, so then it will be created. So here you can see, so first we are using calculate, using the first expression, finding out total order quantity in that week, then using filter, that is past orders. In past orders we are providing is, these are the filters, like we are filtering the past orders table. We are saying that SKU ID should be in the week demand sheet, and past order date should be greater than equal to the week date -6 and should be less than equal to week date. So basically we are trying to get the values within a week, right? And when you will do that, this is the simplest way. And now you will have your weekly demand sheet, and it will change. So in your weekly demand sheet, for every week date, that is for example 15, for every SKU ID, you will have your week demands. Okay, so this way you will have the order quantity now, and now this will help us in creating the graphs. Now we have to create multiple columns, multiple measures in stock table also. So first is like ABC classification. It categorizes inventory based on importance and value. So inventory based on importance and its value. Okay. So here in the stock table, we have our first value here. So when you will go to stock table, so let's go to the stock table. Here you have the ABC and XYZ. Okay. This is ABC rank, this is ABC. So we have to create these calculated columns. So now the first calculated column that we have is ABC question mark. So we are using if stock cumulative share. Okay. So here the dependent value is cumulative share. So cumulative share we are using calculate once again. In calculate we are using revenue share. Okay, that's how, suppose you get a data set or a Power BI file where you have to see, how these calculated values are created. So you can navigate one by one. Like now I can see that in cumulative share, we first have to see revenue share percentage. So we will simply go to revenue share percentage. So the revenue share percentage depends upon annual revenue. Okay, it depends upon annual revenue. So we will start from here. Annual revenue. Annual revenue depends upon annual sale quantity and unit price. Okay, so here we have to get the annual sale quantity, and in annual sales quantity we have order quantity. So in past order, the order quantity is already given. So if you will simply see, so in past order this is already given, so we can start from here. Okay, that's how we started from one column and saw all its related values. So first we will create order or annual sale quantity. I- in annual sale quantity we are using calculate. In calculate, the first expression should be a aggregate expression or expression. So here you can see first is expression, then second argument is the filter. Okay, so we are saying sum of past orders. We are calculating annual sale quantity, that is for the entire year. So this is sum of orders quantity, and the filter that you are using is in past orders table. So in filter you have to use first argument as your table, then second argument as your expression. So past orders SKU ID is stock SKU ID. So whatever SKU IDs are in stock table, first we will use that filter, and this and is logical operator as we discussed. And we are saying the past order date should be greater than the last date minus 365. So last date is 14 June minus in the order quantity. So last date minus 365. So we are just selecting this date. You can also write, select max date from order date. That is also one way. So, but here they are using the easier way, and this way your annual sale quantity will be created without any problem. So you will go to modeling tab, create new column, and here you will simply calculate that. Okay, and here it is asking stock SKU ID. So in stock we do have SKU ID. Let's see why it is not able to read that. So we will select the stock table, and so here we will select the stock table, and since we have to create that column in stock table, not here, so we'll first delete from the model and just click on this and then go to modeling tab, then new column. Okay, so let's say here, and here we are writing a stock table. Now it is available. So now you can see stock SKU ID, and now this column annual sale quantity will be created here. So now annual sale quantity is created. Now since we have calculated the annual sale quantity, if you want to see what can we see in the annual sale quantity. So for example, we have the order date here, right? Let's try to create a very simple type of graph. So we have a order date here. So here in x-axis we will select order date, and on y-axis we will try to select the annual sale quantity. Obviously we are seeing a flat line here, but because this is showing count of sale quantity, we can also select average, but we will try to create this graph in a better way. You can also drill data for different type of values, which you will just see later. So now after creating the annual sale quantity, because this is going to be same, right, annual sale quantity or sum of value, and now after annual sale quantity we will see revenue share percentage. So the revenue share percentage depends upon annual revenue. Okay, annual revenue. So now we will create annual revenue. So in annual revenue, we are using the annual sale quantity and multiplying by their unit price. So quantity multiplied by unit price is the final revenue for us, right? So if in your Excel file, let's say it is given that this is quantity and this is one unit price. Okay, let's say there are four quantity and unit price is 500. So you will multiply 500 by 4, then you will be able to see the annual revenue. Suppose this is the sales or orders table value, right? So that's why we will create annual revenue like this, and I will provide this particular PBIX file to you so that you will get the all these DAX values, but you can use it for your own testing also. Make sure this time you have selected the stock table and then you are creating a calculated column. Okay, so now we are calculating annual revenue. So our annual revenue is also calculated, and you can see annual revenue. And let's say we select a order date, we select a graph. So this time you can see obviously in x-axis we have to reverse it. In x-axis we put order date, y-axis annual revenue. Okay, currently it is all showing the same value. So but we will see everything later. Now next thing we have to do is revenue percentage. And here for example in total sales by week date, that's why they have selected the total sales amount on y-axis and week date on the x-axis. Okay, so whenever you want to see, suppose you get a Power BI visualization file or PBIX file, and you want to see which particular fields are used in a graph. Okay, so if you select that graph for example, so you will see some of the values will be checked. So from weekly demand sheet, sales amount and week date are checked here. Okay, for example, if we do this, and in weekly demand sheet we have SKU ID weekday. So in our weekly demand sheet, first we have to calculate that sales amount value, and this sales amount value is basically the lookup value function that we understood later, so earlier. So here we have sales amount, and in weekly demand sheet it is asking for SKU ID. So let me see why we are not able to select that. So in weekly demand sheet, let's see SKU ID. So even though I selected that table, still it was trying to create in another table. So every time, this is something that we have to make sure when we are working with multiple tables. So that's why we have to select the week table. So when we are inside the weekly demand sheet, we will create a new column here from modeling, new column, and now this will be created properly. So now we have the sales amount. Here if we select week date on x-axis and sales amount on y-axis, so we will have this graph. Obviously this graph is aggregated currently in terms of year. So when you are selecting a week date, let's say we can omit these values, or if you want to keep these dates, for example month and year and day, so we can drill down. For example, we can see now quarterly, now we can see monthly, now we can see daily. Okay, so this is something that you can do in your drill down. So obviously first we have to create our calculated column. So we have created sales amount, week demand, and now let's go back to our stock table where we created annual revenue and annual sale quantity. Now in the stock table we have to generate the revenue percentage. So here we will generate revenue share percentage. So revenue share percentage is going to be stock. So we'll multiply 100 into annual revenue divided by sum of annual revenue plus 0, right? So this is simply percentage of annual revenue. So here we will simply go and create a new column. This is also easier to create a new column in the same table. And here we will generate the revenue share percentage. So our formula that we have used is 100 multiplied by stock into annual revenue divided by sum of revenue. Okay. So in the formula we have 100 into stock annual revenue multiplies the annual revenue of each item by 100 to express its percentage. Then sum of stock annual revenue calculates the total annual revenue across all items in stock table. Division is used to divide and plus 0 likely as a placeholder to ensure the formula does not return error in specific scenarios. Example, division by 0. Okay. So when we are dividing by 0, so that's why for after calculating the entire thing plus 0 is written so that we have at least 0 here. Next, we will try to create the cumulative share. The cumulative share is calculated by adding the revenue share percentage, and in revenue share also we are filtering the stock table. We are saying the stock revenue share is greater than earlier stock revenue share. So earlier function is used to find, obviously as the name suggests, return the value in the column prior to the specified number of table scans. Okay. So earlier we means earlier stock revenue share. So we are comparing this value with the earlier value and filtering according to that. So this will give us the cumulative share. So we can simply create cumulative share also. For that also we will go into stock table, create a new column, and this will create a cumulative share for us. Okay. Now we have the cumulative share. Similarly, we can see all the columns like which we have to create ABC, we have to create ABC rank, annual revenue, annual sale quantity, average weekly demand. In average weekly demand, we are using the weekly demand sheets, week demand, and filtering its SKU ID should be equal to this table's SKU ID. So we will select all of this and we will create the average weekly demand table also. So from average weekly demand column also. So from here. Now as a beginner, this may be a little bit confusing, but when you will create these columns, you will be able to understand it properly. Similarly, we can also create a standard deviation of weekly demand. For standard deviation of weekly demand, when using the calculate function, here the expression that we are using is a standard deviation population. So from the weekly demand sheet, we are using weekly demand, which will tell us the standard deviation in weekly demand. If we have less deviation, that means that uh, the distribution of data range is smaller, like close to mean. If we have higher value in standard deviation, that means data is distributed over a wide range. So here the filter again, you can see filter that we are using is weekly demand sheet, and we are just making sure that all the SKU IDs in stock table are equal to the weekly demand sheet. So you have got an idea of how to create these calculated columns. So on the basis of this, ABC is basically created if stock cumulative share is less than 70, we will say it's a high value. Okay, if stock cumulative share is less than equal to 90, we will say it's a B and medium value. Otherwise, we will say C, a less value. The ABC classification. Similarly, we can do XYZ classification. This will group inventories by demand variability. Okay. ABC does on the basis of importance which we got from cumulative share. So let's see the XYZ also. So here if you will go, you will see the XYZ classification. So if stock coefficient variation rank is less than equal to 2. So for that we have to see the stock coefficient variation rank. So first we will see the stock coefficient variation rank. This is the coefficient variation rank. Here we are using the rank EQ function. Now why do we use rank EQ function? It returns the rank of number in a column of numbers. Okay. If more than one value has the same rank, the top rank of that set of equal values is written. That is equal. So we are using coefficient of variation here. Okay. So the coefficient of variation that is used is standard deviation of weekly demand. So if standard deviation of weekly demand is greater than 0, then we are calculating the stock standard deviation of weekly deviation divided by average weekly demand multiplied by 1000. Okay, this will create coefficient of variation. So for this you can see, we as we created average annual, we also can calculate average weekly demand. So for that we will use the average function. Okay, this will use the weekly demand table and calculate the average function for us. Now once that is calculated, we will calculate coefficient of variation. Then on the basis of that we will calculate coefficient of variation rank. And then if you go to XYZ, so here you can see from coefficient of variation rank, if it is less than equal to zero point 0.2 multiplied by maximum of stock coefficient variation rank, then we will call it uniform demand. Otherwise we will call it variable demand. If stock coefficient rank is less than equal to zero point 0.5 multiplied by max, so we will just correct max. So maximum of stock coefficient variation rank. So if the coefficient in variation rank is less than equal to zero point 0.2, we will say it is uniform demand, X uniform demand. Otherwise we will say Y uniform demand, or else we will say uncertain demand. Okay, that's how you can define the XYZ value. And this XYZ value tells, it groups inventory by demand variability. That's how you can calculate demand variability. So obviously in this part we have to study some more calculated values, which we will continue in the next part. So please subscribe to our channel so that whenever we'll post that video, you will get a notification. And in the next part we will see how can we calculate this particular dashboard or something more interesting than this using other type of filters. And you can see the values that we have created like ABC. So here for example in this table, this is just a table visual. So if you will select this, this is a matrix visual, and in the matrix visual we have selected week date on x-axis, and on y-axis we have selected total sales amount. Okay, and this is the table, sorry. In rows we have selected ABC, and in columns we have selected XYZ, and this is the matrix visual. So this way you can, similarly this is distribution of annual revenue. So the value that we have selected is sum of annual revenue. Similarly here, if you will select this, here this is distribution of current stock. So it is actually taking some time in filtering, that's why. So here we have selected sum of value in WH, and value in WH is nothing but uh, stock current stock quantity multiplied by stock unit price. So all of this will be discussed in the next chapter, so please stay tuned for it. And please see our other tutorials also. Then you will also understand DAX in great detail, because in our tutorials we have explained the use of almost all DAX functions with example. Thanks for watching this video. Have a nice day.